All right, now let's get into some trickier stuff. So, here we be. Let's go. So I got two limits in here. One limit is x is tending towards 3 from the left. One limit is x is tending towards 3 from the right. So we have ourselves a function. They're the same dang function. Right? Same one for both. Now, you don't have a graph. Does everybody know how to graph that? Is everybody cool with that? You just run through, you're just like, I'm just going to sketch a quick graph of this, right? You're like, rational functions. That shit was easy, right? You're like, I'll just graph it up and be able to answer these questions. Of course, I'm being facetious here. I mean, that's not probably the case for most of us. I mean, unless you're at home and you're like, I'll just punch everything into Desmos. That'll be cool. You'll learn nothing. That'll be good. It'll help you in Calc 2. It's not bad to look at a graph and confirm what you're doing, but using one just to answer these, tell me how that works out for you in Calc 2. Okay. This is tricky. So we're going to deal with the problem on the left. We're going to go from the left. Now we're going to get closer and closer to 3 from the left. So the game I choose, like I know this shit is going to, right? If you plug in 3 here, you're going to get a 0 and it's going to create a vertical asymptote because there's nothing to cancel out with it, right? If there was an x minus 3 up top and we could cancel it, that would be a hole. That's what we did in 2.3, not for 2.4. Now we're discussing what happens when you can't. So I know the answer to the one on the left is either positive infinity or negative infinity. I just got to figure out which one it is. So what I'm going to do here is I'm going to choose a number to the left of 3. And what I mean to the left of 3 is I want to choose something that's smaller than 3. But I got to keep it really close. I got to keep it real close. So I'm going to choose a number and I'm going to plug it in. I'm going to call f of something is equal to our, and I rewrite this stuff, minus 1, minus 2, all over the minus 3. And I want to plug in a number that's a little smaller than 3. But I want to get so small that it's 2, because that's going to change stuff up. So I'm going to choose 2.9 and plug that in. Don't worry, you don't have to know any of the freaking numbers. Do you know positive and negative? Sorry, again, my dog hears me talking, and his long-ass nails come in to come say hi. So I'm going to put in 2.9, 2.9, and 2.9. All we're trying to do is figure out what the sign of this is. I don't need to know exactly what these numbers are. So right above, I go 2.9 minus 1. Yes, that's 1.9. But really, I'm just looking and like, dude, that's a positive. And then 2.9 minus 2. Yes, that is 0.9. Cool. Cool story. I couldn't give two shits about what the number is. All I care is that it's positive. And now I look down below at this one and I go 2.9 minus 3. Well, yes, that is negative 1/10. But again, I don't give a crap what this. Who cares? It's a negative. So what happens when you have a positive times a positive up top? Doesn't it stay positive? And then what happens when you have a positive divided by a negative? Doesn't it turn negative? Thus, our limit is equal to negative infinity. Because we knew at the beginning, it's like it's either freaking positive infinity or it's negative infinity. We just got to figure out which one. So I chose a number a little bit smaller than 3. Plugged it in, just checked the signs. And we found out that this was some sort of negative, because a positive over a negative is positive. Let's play the same game on the one on the right. So now we're coming in from the right. Our x values. A number that's bigger than 3. So I don't want to get too far away from 3, so I'm going to make another function. Go, all right, it's f of something. We're going to subtract out that 1. We're going to subtract out that 2. Then we're going to subtract out that 3. And I want to choose a number just a little bit bigger than 3. I want to keep it close, though. I don't want to get too far away. So I'm thinking 3.1. So we pop it in, and we're like, well, what's going on? And we're just looking at the frickin' signs. Some of y'all like can't help yourselves, and you're like, no, 2.1 times 1.1 divided by 0.1. Who gives a shit? It doesn't matter what the numbers are. It only matters what the sign. So 3.1 minus 1 is 2.1. That's a positive number. 3.1 minus 2. That's a positive number. Yes, it's 1.1. 3.1 minus 3 is 0.1. But isn't that, again, a positive number? So I'm pretty sure a positive times a positive is positive. And then when you divide by a positive, that shit stays a positive. So what do you think the answer to this one is? It's positive infinity. So now we look. What's the limit as x tends towards 3, period, of x minus 1 times x minus 2 all over x minus 3. So we look, and we're like, well, the limit from the left was negative infinity. The limit from the right was positive infinity. Therefore, the actual limit does not exist. So this is the trick that we use when we don't know how to graph something. Or we don't want to graph something. Shit, I can graph it. I know how to. I got the skills. But I sure as hell am not graphing that thing if I could just plug in some numbers that are close to 3 and figure out what the frick is going on. So it's up to you. Maybe you're a badass with graphing rational functions and you just look at it. Okay, do you. But this is a method that we can use to determine where things are going. I'm telling you, this is some of the toughest stuff. It's different. You either need to know your graphs or you got to know this technique. So we'll do another one that's a little trickier possibly in the next one. And then we'll start in on some trig stuff because I know most of us have forgotten most of our trig. Huh? It's okay if you have. Maybe you haven't even learned it. But we'll be back in the next.